Can you
Hello.
hear me okay?
Oh yeah, what's up?
Hey man, how's it going?
Good, dude. How are you?
I'm doing well, all things considered. So yeah,
Yeah.
just to give a quick introduction to you, this is going to be a 45 minute to like an hour mock interview where I will
Mhm.
ask you technical questions that you'd probably encounter at any of these larger tech company interviews. And yeah, so for the viewers that are watching and that haven't really seen any of this, when you typically apply to one of the larger tech companies, you'll have phone screens, not on site anymore because of COVID. And yeah, you'll be given a CoderPad document such as this, and you'll talk to an engineer for about an hour, and they'll give you a problem or two, and you're expected to code up a solution to that problem. Quick little plug for the Discord that we're building. So me and a few friends decided to make a Discord where we are helping people that are in the process of interviewing or getting ready to interview to be ready to interview. So yeah, in the bottom right is a link to the Discord. So feel free to join that. And yeah, so that's all I have to say. So why don't you, the person on the call, tell me a little bit about yourself, where you come from, and yeah.
Yeah, so I'm currently a CS student. I'm from Miami, Florida. I go to FIU. But my background, I've interned a couple times in the past at a startup. I was at GoDaddy last summer. This summer I'm going to be at Lyft remotely because of COVID. And yeah, that's sort of my technical background. I sort of just do like full stack web. So what I've been doing for the past like year or two already.
Dope. Yeah, man. It's everyone's remote now.
Yeah.
Yeah, times are tough. So yeah, why don't you go ahead and select what language you want to do this in? It's at the bottom part of the screen.
Yeah, for sure. I think for now I'll do Java.
Cool. I'm always happy to see someone interviewing in Java. Whenever I do these interviews, it's just like Python, Python, Python. And as someone that does interviews myself in Java, I'm like, can I please get somebody in Java?
Yeah.
um, so yeah, let's go ahead and get started. Here, let me import you the package that you need. Awesome. So I'll paste a question, and yeah, let me know if you have any sort of clarifying questions. I'll give you a second to read the question for yourself.
For sure.
An
Okay.
example.
All right. So I'm gonna read the question. Given two strings, function determine if T is an anagram of S. Okay, so by definition of anagram, it's if you could rearrange the letters of S to form T, so to
Right.
speak. Yeah. Okay. And is it possible for one or both of these strings to be like null, for example, like as input?
No, you can assume they're strings, like of at least one character.
Okay. So right off the bat, one thing you could probably do is check if they're both the same length. Because if they're not the same length, then it's not possible for them to be anagram. So that's sort of like one one quick check you could do, like a base case. I suppose another thing you could do, a quick solution is if you were to maybe sort the strings, you could sort them and then check if they're exactly the same. Because if they were anagrams, it means that they have this of letters in each. So if you sort them and do a quick string comparison check, if they're the same, then it would be true. Otherwise, false. That method sorting would be both n log n, or in this case, s log n plus t log n, t log t, whatever. It's gonna be like that sort of runtime. So that's one thing you could do. What I would do in this situation, if we want to go for a quicker runtime, is you could use like a hash map or an array or some sort of table to count each letter and the type. So, for example, S would have two A's, one N, one M, so forth. And then you would do the same with T. And essentially, you just want to make sure that at the very end that they have the same number of letters for each. And if we do the hash map approach, that should be like linear in both space and time. So that's probably the approach I would go for with this question.
Yeah, I like that hash map approach. Why don't you go ahead and start fleshing that idea out a little more into like pseudocode or code, whatever you want.
Yeah, I think I'll just jump straight into code here. So we want to return a Boolean, correct?
Right.
Like true or false. All right, so I'm gonna call this is anagram. It's gonna take in two strings, so string A and string B. So you said both strings are gonna be valid, so I have to check that, but I will check if A dot side no length. If A dot length is not equal to B dot length, then we could just off the bat because there's no way they could be anagrams. So assuming that they're the same length, now we could go ahead and check. How I would do this is I would simply just make a character array, something like this. And what I'm gonna do is through the first string. So for char C and A dot to char array. And for each letter that we're simply gonna actually there should be an integer array. Yeah, because we're gonna keep count. So for each letter, we're gonna sort of just increment a count.
Yeah.
And yeah, so like basically at each since you can map each character to its ASCII value, we made it 256. It's gonna sort of just and now we want to go through the second what's it called? The second string. And we want to decrement it now. Might have to check if I but I could debug that. Anyways, and then so essentially now we decrement it, and if they were the same string, this array should be all zero. If there's not the same string, there's going to be either a positive or negative somewhere in there, and so we can just check for that. So for int I 0 I is less than letters dot length. We check if I probably let me actually write this cleaner. This is probably for each. There we go. So if I is not 0, return false. Otherwise, return true. Yeah, so to quickly go over this again, if they're not the same length, they're automatically not the same string. We make like a sort of hash map table here to keep track of the letter count. For each letter, we're gonna the ASCII position in here by 1, and in the first string, and then we go through the second string and we decrement it. So at the very end, we go through this array we made, and if any of them are not, there was an offset count in one of these, and they're essentially not the same count in both strings, so then we could return false. Otherwise, it's all good and we could return true. So I'm gonna go ahead and test this right now.
Sounds good.
Yeah, so string A, I'm gonna use your example, is this. String B is okay, let me run it.
Static, yeah.
Yeah, always forget that. I actually don't use Java like sort of like for my own projects. I use it just for interviewing. I use
Oh, I'm
JavaScript
the
for
same
interviewing.
way. Yeah, I'm a TypeScript, JavaScript person too.
Sweet. Okay, yeah. So this return, make it not true and see if it still works. Yeah. So that looks like it's good.
Cool. Um, yeah, this seems to be a working solution, and yeah, it's definitely linear to respect of whatever the length of the strings are.
Mhm.
So yeah, let's go ahead and move on to the next part of the question.
All
So we
right.
know what an anagram is. Let me paste the second part for you. So if we're given like a list of strings, I want you to group these strings together such that like the first group would be referring to the anagram of ATE, and the second
Mhm.
group would be NAT, and the third group would be BAT. So essentially, for every certain group that we have of like a representation of an anagram, I want you to return another list of that with like the respective strings in that list.
Right. Okay. Um, cool. So basically, yeah, you want to group all the anagrams, separate lists. Let me think of any possible things I can to account for. I guess same thing applies. There's still no like null strings or anything like
Right.
that.
You can assume they're always a string with one character.
Okay. Um, so let's see what kind of brute force solution to this. So I guess like one right off the bat brute force way, if we go along the same logic above, is to sort all these strings. Um, sorting all these strings, and then that probably wouldn't give us that much input. Um, what I feel like doing here is we're definitely going to use another sort of hash map again. I think what I'll do is through each string, I'm gonna like first sort it. So for example, we have eats. If we sort that string, it becomes EAT. And there's no sort of like right now the hash map is empty. So let's say we just add this to its own list. And we're gonna make this like a key. So and then we're gonna add like itself to its list. So AET. Then we come across the second string T. Once again, we're gonna sort it. And when we sort it, it becomes AET again. So now that we've already encountered one string that's been sorted in the hash map, we could check for like if that key exists. It does exist, so then we can add it to like sort of that list that we already made. So then we add T here. T. When we get to tan, we sort that, it becomes A and T. We don't have a key for that, so we make it and then we add itself to its list. And we sort of keep going in that logic. So when we come across A8, it becomes AET, and then we add that here. Nat becomes ant when we sort it, and then we add it to this list. And then finally, bat becomes ABT, and then we add itself to that list. Yeah, so I think which I would do. If we do it that way, let me think. We're iterating through each string, so that's linear. We're sorting each individual string. Um, so it's something like we go of n times n log n. Yeah, I think that's the runtime. If we assume that n is like, well, actually no, we
It
can't
would
assume
be
that.
a different variable name, right? Yeah.
Let's just say it's like k, which is k is like the number of strings, and then n is like the average size of each string. So it'd be something like this: k times n log n.
Mm-hmm.
That's
Um,
for time, and then space would just be big O of k.
right. Yeah, this
Yeah,
sounds good. Could we do better than n log n? Could we maybe like improve on that?
right. So we already have what's it called? This is no, actually, can we use this? Is anagram. My approach was using the keys sorted. This method here. Let me see if I can somehow use this. Is anagram, is anagram. If we're trying to use this method, we would have to sort of do for loop on each, I want to say, and that's probably not going to work too well.
Why do you say that?
Well, let me see, because we want to check, because if we start with EAT, and let's say we use this is anagram, which is already linear, we compare it with, say, the second one, we would have then with tan and 8, and so forth. Hmm. But if we did that, the okay, I think I have an idea. If we test do something here. Let's say we take this list and let's say we start with this first one and we test it with TEA. So we do that and we using the method, we see that they are anagrams. So let's say we can sort of exclude them, so to speak, I guess. And then we keep cheats with tan and 8. Tan doesn't pass, but 8 does. So then we could sort of exclude that one and then add it here. And then we check nat and bat. So then we have this list. And all we have to do now is we have a new list. Then we start with this one, tan, and then we check nat and bat. And then these two belong to their own list. The bat is on its own. And then we're done, so to speak. Okay, so we do that. I want to say that's it's probably linear.
Yeah, it sounds to be linear with respect to like the.
The number of number of student ones. We don't know.
I'm sorry, you're breaking up. What did you say?
Oh yeah, I said that we go through the strings once, then
Mm-hmm.
we sort of like so that is a linear that is a linear fashion, I guess. So then what would be the runtime of that? Just be k times n, I
Yeah.
suppose. Yeah. Yeah, that's definitely better. Okay. So I guess I can go ahead and do that. Now
Yeah.
the one thing I'm trying to quickly think is how do I sort of mark them as like done? Um let's see. The quickest thing that comes to mind is to use a set, uh, like a quick hash set, and then just keep adding it as you're finished. And then if it's not in the set, just skip it, I guess. That might work, I guess. Using a little extra space to keep track of which ones we finished. Cause because this is an array, so we can't just like remove it so easily, so to speak. How does that sound?
I'd like to see more if you. I mean, yeah, it sounds good, but I think there might be a caveat to like what your approach is. But I can't really say. Yeah, I'd have to see you implement it first. Like start implementing it.
All right. Yeah, we can just try to start doing that and see how it goes.
Sure.
All right. So public static, and I'm gonna do list of string group anagrams, and it takes in a string array words. I don't think there's any base cases here, so yeah, let's just skip that. Oh, okay.
Yeah.
So first thing I'm gonna do is just make this sort of list we can work with. Okay, so and then no matter what, we want to start iterating. So for string s in words, then so I just said the way I'm going to do this is let me check. No, let's do this actually. Size 0 y is less than. Okay, we're gonna have to sort of at first do the before loop. I'm gonna have to figure out a way how to skip it for the other cases. So do for int j is equal to I plus 1 while j is less. So sort of a quick rough outline of this. I'm going to use if is anagram. words of I, words of J, and we need to make a new list here. So let's do string list, array list, so that we could start adding this stuff to it. We want to do list.add. Now the thing that I'm seeing here is there might be duplicates if I do this. Okay, I have an idea. Let's do this first. Add words of I. And then if it's an anagram, we have words of J. Okay, so right here, this is n squared. So at one point, I need to optimize this. So initially, I was thinking of using a set. So let me try that idea. So set of string. All right, so let's see. List at I. So I want to do something like set.add words of J. And then here, set contains words of I. Continue. All right, let me look over this real quick. So if it contains the one we've seen already, we continue. Otherwise, we start iterating. Otherwise, we add it to our list. We add I, then we start iterating through the second one. If it's an anagram, we add the anagram, and then we add that to our hash set. And then at the very end here, when we're done with this outer for loop, we want to do output.add. Actually, just list. And okay, so what I'm doing here is I'm doing first for loop starts at the very first position. We have a set of words that we've already seen. If we've seen that word already, like sort of if we process it, we just continue. Otherwise, we make a new temporary list. We add the first word we're looking at. Then we start iterating through the words in front of it. If they're anagrams, we add that list to our temporary. We add that word to our temporary list, and then we add it to a set that we are keeping track of. Once we're done with this first outer for, we add the whole list to the output, and then we just keep going. And when we come across, say, T, we already added that to our set, so we don't have to go through the whole double loop process again. And we keep going until we encounter one that we haven't seen yet. Yeah, I think that sort of fixes that n squared problem. What do you think?
Yeah, no, I see your approach now. So basically, you're saying you're adding it to the set only on the condition that it's either an anagram
Mm.
or yeah, just that condition, right?
Yeah, pretty much. If it's an anagram, it means that we've already like processed it, we've seen it already, so then we don't have to look at it again, and we only come across words we haven't seen that aren't anagrams.
Right.
Yeah,
Yeah.
I mean that's sort of like the first approach I thought of. Maybe there's a better way of doing this, but
Yeah,
this is how I would do it.
there's like a simpler way to do this. I'd have to think more about the runtime complexity because I haven't actually seen a solution like this, if I'm gonna be honest. But the way you had like a really close runtime, you had like O of k and k times n log n, and the only reason you were hitting like the n log n was because you were sorting each string, right? And that would give you like an n log n because you're
Right.
sorting. Um, so what if there was a way you could maybe generate like a hash code in linear time rather than like n log n?
Oh, okay. I see what you mean. I believe there is a There is a built-in method actually. I don't think I've used it before, but
Well, you you have this is anagram function where you're kind of using like a hash code approach with like the table. If you could basically structure it like on line 28, you have this table, you made this table and you're kind of populating it right on
mhm,
like the first for loop.
yeah.
You could make a hash code based off that array, right? Couldn't you?
Mm. So
If you just built it up as you iterated through that array.
when you say hash code, I'm not sure like I'm getting at that. What you mean by that though?
So imagine if we had like the string like a, um, and we have that within our letters table, right? And then what we'd want to do to build that hash code is walk through that letters array and then have some
Mhm.
sort of like algorithm to just like generate a string such that it would be like 1A to represent that there's like 1A in that letters table. So like it
Okay.
would be like the amount of times you have that
Mm.
letter in the
Okay.
table and then
I
that
see what
letter
you mean
itself.
now.
Yeah.
Okay, so you're basically saying like generate this sort of code for each string and then use that as the key in the hash map. And
Yeah, because
then
that would be
yeah.
faster than your nlogn, right?
Yeah, that is faster than that for sure. Okay. That's interesting. I didn't think of that. Um Let me see how much time. We got time. So I guess I could try that approach then. Okay. Let me go ahead and do that. So I'll just make a whole new method for that, I guess. Something like public string generate hash. So we're gonna copy this, right? Um, mm, and then you said to do like 1A, 2B. Is there a simpler way of doing it? Do that.
I think you could do like
I think just like doing a hash map,
yeah.
basic hash map. Yeah. Map of character. Share map. Okay. And then for the hash itself, let's see. If I remember how to iterate through a hash map properly. I think it was something like this. No, wait. For see if you can help me out. I kind of forgot how to iterate through a hash map.
Yeah, I kind of forget
Um,
too. I kind of just have I do like it would be map dot key set and then you can iterate over that. It would give you the keys and then you can grab the value. It would be
um,
like that and that would give you all the keys and then you could just grab the value in that for loop.
okay, I got
I think that yeah, there is a different way to do it with like map.entry, but it kind of
you.
escapes
Yeah,
me too.
it's cool. All right, so I can just work with this. So we could say it's about. All right, and then we want to do something like sp.append val plus c. So once we're done with that, turn sp.to.
Right.
All right, so that's sort of our hat. So now, yeah, this actually is that is a better way of doing that. So we don't need this anymore. We definitely don't need this double for loop anymore. Yeah, I'm just gonna start from scratch here. So can actually just do this now. And we do need our hat. It's gonna be a string to a list of strings. So string hash is equal to, what do I call it? Generate hash. S if map dot contains key. Oops. Is it? All we have to do is map dot get hash dot add the string. Otherwise, I'm gonna say new list. We're gonna add the word, and then we're gonna add a new entry to the hash map. Okay. And then, oh yeah, now we have to go through this again. So what was it? Let me see. For char C method. So it's for list string map dot key sets. What we're gonna do is output dot add list, and then return output.
It's kind of like that. You're getting a string from your map.key set on line 108, not a list.
Am I?
Yeah, yeah. It's holding a string as a key.
The what's it called? Oh, this is key set. So is there value set?
I actually don't know. Maybe.
Well, let's
Let's
see if
just
it
pretend
is.
there is. Yeah.
Actually, I think map dot. Yeah, you could probably just check after. But anyways, yeah, I'm just gonna run this now and see. Okay, so that one works. So let's just do. Where's your? Here we go. Okay, so let's just do string array. String array. I'm gonna use all the. Here we go. Okay, and then group anagram. Now for Java can be annoying sometimes. These
Yeah,
typing
man.
errors.
Yeah, it's pretty annoying, honestly.
Okay, and then we could just print that out. All right, let's just
You're
run it and see.
missing. Here, hold on. There you go.
Oh, my bad. All right, so let's just see what happens here.
Ba-ba-ba.
I think
Oh, you have a random.
Oh,
It's not a method actually. The value set.
mm, I think I'm gonna take a shot at dark and try to remember it. Or was it down here? I think it was this. I think.
That does look familiar, actually. Yeah.
I'm pretty sure. I'm pretty sure I've used that before. No.
Man.
All right. I'm gonna. Yeah, I'm just gonna Google it real quick.
Yeah, go for it.
All right. Java hash map. Oh, this just dot values. Okay.
Oh, really? Okay.
There we go.
Uh, yeah, yeah. That's it.
Yeah, and then that is what's it called? K times n runtime for sure.
Right. Yeah, I like that approach a lot more. It's a bit kind of hard to identify that you could optimize from sorting the strings to just like making a hash shit on the fly. But yeah, it's like a
Yeah.
really good way to improve your runtime for sure.
Yeah. Thank you for letting me know. I didn't know that.
Yeah, for sure, man. Yeah, I really enjoyed doing this with you, by the way. I appreciate you taking the time out of your day to do this with me.
Yeah. Yeah, for sure. It was definitely beneficial for me.
Yeah, for sure, man. So yeah, if you are still watching, make sure you check out the Discord. It's in the bottom right. Yeah, we'll be doing resume reviews, leak code practice, all that fun stuff to help you get ready for the interview grind that's starting next fall for summer 21 internships and all that fun stuff. So yeah, thanks for watching, guys, and until next time.